Hello students, in today's video we are going to cover the transformations that comes in O levels maths D exams. So basically there are four types of transformations. The first is the translation, second is reflection, then rotation and enlargement. So in this video we will cover all these four transformations one by one. So let's start with the translation. Okay, let me explain you the translation with the help of an example. So I have a grid and the triangle A and triangle B are drawn on the grid. In A part, describe fully the single transformation that maps triangle A onto triangle B. So as you can see, A to B, the shape is same and the size is same. It is just a translation and we need to find how much shape A translate to get the shape B. Okay, so translation is horizontal translations and the vertical translation. So first we need to find the horizontal translation. As you can see, this point on A will be this point on B, right? So we have 1, 2, 3. So we move 3 units to the left and 1, 2, 3, 4. 4 units up, right? So it is basically a translation and we can say translation. And how much it is translated? 3 units to the left. So for left we can say -3 and 4 units up. For up we can say +4, right? So keep in mind, for when we are explaining or expressing the translation, the first is always for the horizontal translation. It can be positive or negative if it is towards right or towards left. And the second one is the vertical translation. If the translation it is up, then we can say positive, and if it is in down direction, so we can say negative. Now for the B part, draw the image of triangle A after translation when the vector is 4, -1. So in the first part we have given the shape A and the translated shape B as well. We just defined how much that shape is translated to get B. Now for the second part, when the shape A is given, how can we translate that shape? By using this vector to get the new shape. So 4 and -1, it means 4 is a horizontal translation and -1 is the vertical translation. So 4 is positive, so we need to move horizontally 4 units to the right. Okay, so if this point we consider, we have 1, 2, 3, 4, 4 units to the right and 1 unit down and 1 unit down. We have this point. Now from this point we have 1, 2, 3, 4 and 1 down. This point. This point will be 1, 2, 3, 4 and 1 down. This point. So we have the triangle C. After translation, 4 units to the right and 1 unit down. This is your triangle C. Second translation is a reflection, right? So I made the two tables and these tables will explain you the transformation in reflection, their matrix and their points and their image points, right? So if we have a reflection in x-axis or in y-axis or along a line y equals to x or along a line y equals to -x, these are the matrices and how the coordinates or the points are going to be changed, right? So let's do an example on reflection, right? Now for the first part, describe the transformation that mapped triangle A onto triangle B. Okay, so as you can see on the grid, we have two triangles and we need to explain by which transformation we can map triangle A onto triangle B. Obviously, it is a reflection. Now by using the coordinates, we can check the reflection is along x-axis, y-axis, along a line y equals to x or y equals to -x. So as you can see, the point on A is this point, x is 0 and the y is 1. And this is a point on B. Here x is -1 and the y is 0, right? So the point 0, 1 changes to the point -1, 0. It means the point x, y changes to the point negative of y and x. Check on another point. If I can take this point on A. So here x is -1 and the y is 3. So we can say -1, 3 changes to it would be this point on B, that is minus 3 and 1. So we have minus 3 and 1. Right. So how can we change the xy? So x is minus 1 and the y is 3. So it is changes to negative of y and the x would be positive 1. So minus y minus x. So let's see what type of reflection is this. Minus y minus x. Minus y minus x. So when it is a reflection in a line y equals to minus x, xy changes to minus y minus x. So we can say that it is a reflection along a line y equals to minus x. Right. Now for the B part, they said reflect the triangle A along a line y equals to x. Okay. And keep in mind for A part, the matrix representing the reflection along y equals to minus x is this. In some question, they ask the matrix as well. So you need to write down the matrix 0, minus 1, minus 1, 0. Right. Now for the B part, we need to reflect the triangle A along a line y equals to x. So for y equals to x, we need to use these coordinate system. X, y changes to yx. And we will get the reflection along a line y equals to x. So let me change xy to yx. Now for the coordinates of A, we have xy changes to yx when we reflect along a line y equals to x. So we have this point is 0, 1. This point is, we can say 0 and 3. This point we have minus 1, 3. Right. Okay. Now xy to yx. Now 0, 1 changes to 1, 0. X is 1 and the y is 0. This point. 0, 3 changes to 3, 0. This point. Minus 1, 3 changes to 3 minus 1. This point. So this is a triangle C after a reflection along a line y equals to x. So you can see by using the coordinate formula, we can easily find the reflection. And the matrix representing this reflection along a line y equals to x is 0, 1, 1, 0. Right? Here we have another example of reflection. In part A, they said describe the transformation that map shape A onto shape B. Okay, so as you can see, we have given a shape A and a shape B. It is again a reflection, so we can guess the coordinates of the reflection. We have 1 minus 2 changes to this point, that is 1, 2. It means xy changes to x and minus y. You see, 1 minus 2 changes to 1, 2. So xy changes to x minus y. Now let's see in the coordinate system what type of reflection is this. So as you can see in the coordinate system, xy changes to x and minus y. So it is a reflection along x-axis, and the matrix representing this reflection is 1, 0, 0, minus 1. Right? So it is a reflection in x-axis. So we can say reflection in x-axis, or we can say along a line y equals to 0. Now for the B part, reflect the shape A along a line y-axis, or along a line basically x equals to 0. Right. So when we reflect the shape along y-axis, we need to use these coordinate system for y-axis, right? So xy changes to minus yx. So if we can use these coordinate system xy to minus xy, we can easily find the reflection of shape A along a line y equals to x equals to 0 or y-axis. Okay, now let me do it. This point is 1 and minus 2. It changes to minus 1 and 2 because x changes to minus and y stays the same. Minus 1, minus 2, this point. This is 3 and minus 2 changes to minus 3 and minus 2. And this point is 1, minus 4 changes to minus 1, minus 4. This is the last point. This is 5 and minus 4 changes to minus 5, minus 4. Minus 5 and minus 4. This point. So this is a reflection along a line along a line x equals to 0, or we can say y-axis. This is a shape C. So by using the coordinate system, we can easily reflect the given shapes, and the matrix representing this transformation is this is along y-axis. So the matrix representing the transformation along y-axis is -1 0 0 1. Now the third translation is enlargement, right? So let me explain the enlargement by using an example. So in question 3a part, describe fully the single transformation that mapped shape A onto shape B. Okay, so as you can see, the shape A and shape B, it is basically an enlargement. We need to find its scale factor and the center of the enlargement. So you can see this is 1 unit and this is 1, 2 and 3 units. So 1 changes to 3. So we can say the scale factor is equals to 3. Now we can check the scale factor is positive 3 or negative 3. So positive or negative sign depend on the center, right? If the shape is on this the same side of the center, we can say it is positive. If it is opposite side of a center, it would be negative. So let me find the center. To find the center, this point on A enlarges to this point for B. So we need to connect these 2 points first, right? This point enlarges to this point. Connect these 2 points as well, right? And the last, this point enlarges to this point. Let me connect these 2 as well. Right. So as you can see, all the 3 points passes through this point. Here x is 4 and the y is 2. So 4, 2, we can say this is the center of enlargement. So on the same side of center, we have the shape, the enlarged shape. It means the scale factor is positive. If it is on the other side of the center, then it would be negative, right? So the given shape, we can say it is enlargement with the scale factor of positive 3 and center of enlargement is 4, 2. So this way we can easily find out the center and the scale factor of the enlargement. Let me do another example of enlargement. In question 3b part, triangle A is mapped onto triangle C by an enlargement. Center is P, this is P. Scale factor is -1/2. On the grid, draw and label triangle C. So before we have given the enlarged shape, we just need to find the center of enlargement and the scale factor. But now we have given the center and the scale factor, we need to draw that shape, right? So this is P, and what is the point P? The point P is -2, 2. -2 and 2. This is the center. Okay. So, and the scale factor, it must be -1/2. So this negative sign represent that if the shape is over here, then on the opposite side, this is the center of that enlargement. So on the opposite side of the center, the enlarged shape must be over here. So that this is the negative sign shows that it is opposite to the center, and half means if it is 2 units, so the new shape will be just 1 unit. Okay, so I will show you how to draw the enlarged shape by 2 ways. So by using the first way, again we can do the same steps. We can connect this point with the center. We can connect this point, all the points of that shape with the center. Yes, with the center. And the third point is again the same, is going to connect with the center, right? Okay, now we need to check. It passes through exact which point. So it passes through this point and this. So this will be, this is 2, so it must be half. So this is 1, 2, 3, 4, it must be 2. So we have 1, 2, this point. So this is the enlarged shape after the enlargement with a scale factor -1/2, and the center of enlargement is -2, 2. Okay, now let me show you the second method, how to find that shape. If this method is hard for you, then we need to find the coordinates for A. So as you can see, from the center, we have this center. From the center, we need to find all the points for A. So we have to move 1, 2, 3, 4. 4 units to the right. We moved 4 to the right and 0 up or down. For this 1, 2, 3, 4, 5, 6, 7, 8. For this point we move 8 to the right and 0 up and down. And for this point 1, 2, 3, 4, 4 right and 2 up. So we have a point 4, 2. Right. Now all these points are going to multiply with the scale factor, that is minus 1 by 2. So let me multiply it with minus 1 by 2 times with minus 1 by 2 and times with minus 1 by 2. Okay. Now this would be minus 2, 0. This is minus 4, 0. And this will be minus 2, minus 1. So these are the new points for the triangle C, right? Okay, now this point is minus 2, 0. So from this center, we need to move 2 units to the left and 0 units up and down. So 1 and 2. So we moved 2 units left and 0 up and down. We got the first point. Minus 4, 0. 4 units to the left, it means 1, 2, 3, 4. So this is the 4 units to the left. Now for this point, we have 2 to the left and 1 down. So 1, 2 left and 1 down this point. So these are the two ways to find the enlarged shape. Last transformation is rotation. That is number 4th transformation. So I made the two blocks. The first tells you about the type of rotation, the point before rotations, and the image point after rotation. When it is 90-degree clockwise, anti-clockwise, 180 clockwise, anti-clockwise, or 270-degree clockwise or anti-clockwise. Mostly in O levels exam, they gave you the for 90 or for 180, not for 270. Now for these are the points that are going to change like with the same like we did in the reflection, and the matrix representing those rotations for 90 clockwise, anti-clockwise, and for 180 clock and anti-clockwise. So let me explain you this rotation by using an example. So triangle A is mapped onto triangle B by a rotation 90-degree anti-clockwise. The center is origin. Draw triangle B. Okay, now it is a rotation 90-degree anti-clockwise. Now let me check how can we find the coordinates for that triangle B, 90-degree anti-clockwise. Okay, so if we use that table, 90-degree anti-clockwise, so xy changes to minus yx, right? So let me write it down. So xy, we need to change the xy. Xy changes to minus y and x. Okay, so this is the first point. I can say 2 and minus 4. So 2 minus 4 changes to what point? Minus y and x. So y is going to be changed with negative sign. So it would be positive 4 and 2. So we have positive 4 and 2, this point. This point we have 3, negative 4. 3 minus 4 changes to minus y and x. 4, 3. 4 and 3. Now this point 3 minus 2. 3 minus 2 changes to minus yx. 2, positive 3. 2 and positive 3. So here is the triangle B after a rotation 90-degree anti-clockwise. So same if you have given any rotation 90-degree or 180-degree or 270-degree clockwise or anti-clockwise about the origin, you can easily find the new shape by using the coordinates, the formulas for these coordinates, and the matrix representing those transformations are also given. Like for 90 anti-clockwise, the matrix is 0, 1, minus 1, 0 in this case. I hope you understand all the 4 transformations that we did in today's video. If you still have any queries, please let me know in a comment section. Thank you for watching. See you next time. Take care.